Hello everyone, today it's my great honor to present our work, Self-supervised fully spatial-temporal feature learning via order prediction of sequential point cloud clips. I will introduce with the following outline: the motivation, our approach, experimental results, the conclusion, and the Q&A. I will start with the motivation. So 3D action recognition is one of the 40 feature learning tasks. It normally takes the point cloud as input and outputs the recognition results. Like in this video, the action will be sitting down. However, due to the problem of large-scale point cloud, and especially for 3D sequences, and a variation of scenario objects, it will lead to the problem that is very expensive and time-consuming to annotate ground truth labels. Then here comes our motivation. We would like to apply self-supervised method to do the 4D spatial temporal feature learning. And as shown in the figure, we through 4D scene networks, and we input the point cloud clips, and it is shuffled. And then we predict the order of them, which is a BDAC, to learn the dynamic features of these 3D point clouds. And here is our approach. This is a structure overview of our network. It mainly contains 3 units: the tuple clip sampling, the feature extraction, and the recurrent order prediction network. So the first one is the tuple clip sampling, and from the raw RGBD sequence, we generate the point cloud sequences through the registration, which will be introduced later in the dataset part. And then through the sampling process, we select the point cloud clips from the n frames. And we shuffle these clips to serve as the further input of the following network. And we choose the 4D MInkNet and MeterNet as our feature extraction network. 4D MInkNet is the grid-based method, and MeterNet is the non-grid-based method. So the recurrent order prediction network is that we take the shuffled clips as input to each of the 4D scene networks they are shared with, and extract feature vectors. Then the recurrent order prediction network contains the LSTM structure and several fully connected layers to predict the correct order of these shuffled clips. So let's say the experimental results. I will first introduce the dataset we use in this paper. First, the NTU RGBD dataset. RGBD dataset is a large-scale video dataset, and it contains the 16 action classes captured by 3 Microsoft connected cameras. And from this NTU RGBD dataset, we generate our new NTU PCLS dataset. We align the RGBD frames and depth frames in this dataset using the quadratic relation to describe the spatial alignment. And we further use another MSR Action 3D dataset to conduct the transfer learning. It's a small-scale dataset and contains the 567 depth map sequences and 20 action classes. So the first one is a temporal order prediction result. We can see the average accuracy of 2 networks are both higher than 79%, which shows a correct and effective order prediction result. So, and the following is the nearest neighbor retrieval experiment. We can see we test the result on the 2 networks, the MInkNet and MeterNet, and the performance with our pre-trained model are both higher than the one that trained from scratch. We also show some qualitative results. The first column is the query frames, and then the results of MInkNet and MeterNet. We can see there are some error in the MeterNet, which is shown in the red color. So here is the transfer learning results to the action recognition. And the 4D MInkNet with our pre-trained model achieves the best performance over all of these methods. Supervised method to learn the 4D dynamic features. And we introduced a recurrent model, we created a new dataset, and we deployed 2 4D scene decoders to conduct the experiment and verify the effectiveness of our proposed method. Thank you. Is there any question?